BERT, bidirectional encoder representations from transformers, is widely used for tasks such as sentiment classification, chatbot question answering, text prediction for emails, document summarization, and differentiating word meanings. BERT is lightweight and can be trained on a single GPU. BERT employs an encoder-only architecture paired with extensive training data. Its multi-head attention mechanism learns diverse patterns, with each attention head focusing on different aspects of the input. BERT encompasses 4 key concepts: bidirectionality, encoder, position embedding, and self-attention. We are going to break these concepts down with examples. The bidirectional nature of BERT allows it to understand context from both directions in a sentence. Unlike models such as Word2Vec, which are unidirectional, BERT can determine that BERT in a sentence about transformers refers to an algorithm rather than a character. It achieves this by calculating attention weights for each word in the sequence, understanding that word algorithm is more relevant in context than other words. This capability makes BERT particularly effective in accurately answering chatbot queries. BERT uses only a transformer encoder. In BERT large, for instance, the input is a composite embedding of word, segment, and position tokens. These embeddings are passed through 24 encoders, each with 16 attention heads and 10 24-dimensional embedding vectors, to compute the representation of each word. Position embedding, one of the 3 input embeddings, records the absolute positions of words in a sequence. This is crucial because the position of a word significantly influences its meaning. An improvement seen in some GPT models, like Llama, is the use of more advanced position embeddings, such as rotary position embeddings, ROP. Within the encoder, BERT uses multi-head attention mechanism to calculate the attention weights of each word in relation to the entire sequence. To understand self-attention, consider a sentence represented by 4 words, each with a 5-dimensional embedding. The first step is to derive a query vector, 4 by 3, which lists the words paying attention, querying to others. Next, a key vector, also 4 by 3, is derived, representing the words being attended to, key words. The dot product of the query and key vectors, scaled by the square root of the key dimension, square root of 3, gives the attention weights. Higher weights indicate stronger influence of the key word on the query word.